Imagine there were a camera capable of seeing through complete darkness, sensitive enough to detect a single photon of light, the smallest unit of light that exists. Now point that camera at your own body, standing still in the dark, with no external light source whatsoever. What it would record wouldn't be a lifeless, dark, invisible body. It would be the outline of a human being glowing in the darkness. This isn't science fiction. Every living human body emits light all the time, spontaneously, without needing any external source. It's not the light you reflect from a lamp or the sun. It's light produced by your own body, radiating from your skin in every direction. The reason no one has ever noticed it is simple. The intensity of that light is about 1,000 times weaker than what the human eye can detect. To give you a sense of scale, if the light from a burning candle were represented by a full bar, the light from your body would be a microscopic mark at the very beginning of that bar. We are quite literally blind to our own glow. Kind of a shame, isn't it? Wouldn't it be amazing if we could actually see everyone surrounded by their own light? But here's the big question. Where does that light come from? It has nothing to do with body heat, and its intensity changes depending on the time of day you're measured. Your body doesn't glow the same way all the time, and the reason only makes sense once you understand where that light actually comes from. For decades, scientists suspected that this light emission existed, but they had no way to record it. It's simply too faint for any ordinary camera, even the long-exposure cameras used in astronomy. The breakthrough came when Japanese researchers developed an imaging system using a CCD camera cooled to extremely low temperatures, the kind of technology used to detect light signals so faint that, in any other camera, they would be lost in the electronic noise of the sensor itself. Volunteers were placed in a completely dark room, with their upper bodies uncovered, and left there for 15 minutes so that both their eyes and the sensors could fully adapt to the darkness. Only then did the camera begin taking images, one every few hours over the course of an entire day, creating what was essentially a photographic timeline of a person's own glow. The result was a visible human outline emerging from the dark background, glowing faintly but steadily, especially around areas like the face and torso. For the first time, this luminosity had been photographed, turning a long-standing suspicion into a tangible image. One important detail makes all the difference when it comes to this glow, and it's worth clearing up a common misconception. Bioluminescence, the glow of a firefly or a jellyfish, is produced by an enzyme-driven chemical reaction that the organism actively controls and switches on as a signal, usually to communicate or camouflage itself. The glow of the human body is something entirely different. It isn't a controlled phenomenon. It arises as a byproduct of metabolism. Inside every cell, the reactions that generate energy also produce chemically unstable molecules carrying extra energy, the so-called free radicals and other reactive oxygen species. Think of them like little balls pushed up a hill. They don't stay at the top forever. They roll back down. When these molecules roll back down, returning to a lower energy state, part of that excess energy is released as a photon of light instead of heat. This happens cell by cell, continuously, in every part of your body where metabolism is active. A single cell releases photons far too rarely for any ordinary camera to detect. But billions of cells doing the same thing simultaneously, each on a tiny scale, add up to a faint yet measurable glow radiating from your entire skin, like the combined effect of millions of tiny points of light that are individually invisible. In other words, you don't glow because your body decides to emit light, or because there's some specialized evolutionary mechanism designed for that purpose. You glow because being alive means burning energy, and burning energy, in incredibly tiny amounts, also produces light as a side effect. If this light is a byproduct of metabolism, it makes sense to ask, does it change when metabolism changes? The answer, based on direct measurements, is yes. Over the course of a day, the same body was photographed several times at different intervals, and the intensity of the emitted light changed in a predictable pattern. It was weakest early in the morning, gradually increased throughout the day, reached its peak in the late afternoon, around 4 o'clock, and then declined again during the evening. If you plotted that variation as a curve, it would slowly rise through the morning, peak in the afternoon, and fall again at night. Almost like the shadow of a sundial, except it measures light instead of time. This pattern was repeated across different volunteers, reinforcing that it wasn't just an individual coincidence, but a shared biological rhythm. The researchers also measured cortisol, the hormone associated with the body's daily energy cycle, and found an inverse relationship between the two. When cortisol levels were lower, the emitted light tended to be more intense. So your body's glow isn't a fixed constant. It follows a biological clock, rising and falling along with your cell's internal rhythm of energy production. almost like a silent visual marker of your metabolism at work. You might be thinking, come on, that's probably just body heat, like a thermal camera image that any infrared camera can easily detect. That's a reasonable assumption, but the data themselves prove otherwise. When the researchers compared the light emission images side by side with thermal images of the skin's surface taken at the exact same time, they found no statistical relationship between the two. In other words, the warmest part of the body wasn't necessarily the part that glowed the most, and the changes in temperature throughout the day didn't match the changes in the emitted light. Two images of the same body, at the same moment, telling two very different stories. That means the body's ultra-weak glow carries information that's different from temperature. It's linked much more directly to the chemical activity inside the cells than to the heat they produce. Heat is energy spreading out. This light is energy being released in a brief pulse at the exact moment a specific molecule returns to its resting state. These are two distinct physical phenomena happening simultaneously in the same body without overlapping. Now, if you're starting to think you're some kind of special being because of this ability, hold on a second, because this glow isn't exclusive to humans. Researchers have recorded the same type of ultra-weak light emission in plants, bacteria, and other animals. It appears to be a shared property of any living cell that carries out oxygen-based metabolism, from a leaf exposed to sunlight to the tip of your finger right now. Isn't nature incredible? And there's one final detail that ties everything together. This light emission stops the moment an organism dies. It's not the result of background radiation or naturally occurring radioactive elements in the body. If it were, it would continue after death at the same rate. Instead, it's directly tied to the process of being alive, breathing, metabolizing, cell by cell, and it disappears along with it. At that moment, you simply go dark. Today, some researchers are studying whether changes in this glow, brighter, dimmer, or shifting in its pattern, could reveal changes in the body's internal state, such as oxidative stress. It's still an area of ongoing research, not a ready-to-use medical test, but it suggests that this light may carry much more information than it seems at first glance. So, to answer the question from the beginning of the video, yes, your body is glowing right now, producing light in the visible and near-infrared range as a direct byproduct of billions of energy-producing chemical reactions taking place inside your cells. You can't see it because its intensity is about 1,000 times weaker than the sensitivity limit of your eyes. The bigger implication is that, in physical terms, being alive has its own unique luminous signature, one that rises and falls with your biological rhythm throughout the day, and disappears at the exact moment the chemical life of your cells comes to an end. Even before a heartbeat could be measured, your body was already telling the story, in photons, of how much energy it was processing. Now here's a big question. If this glow exists, could a person, or some animal, actually see it with the naked eye? Many people say that animals can see things we can't, and can even see in the dark, well enough to move around in pitch-black environments. Then there are those who claim they can see other people's auras. Could that aura actually be the light naturally emitted by the human body? Let me know what you think in the comments. Based on what we know today, the answer is no. There's no credible scientific evidence supporting either of those claims. In the end, science has shown that every living organism, including human beings, is also a source of variable light. Too faint for our eyes to detect, yet significant enough that science can't ignore it. If you enjoyed discovering something that's been literally right in front of you and inside you, the whole time without you ever noticing, subscribe to the channel, because in the next video, we'll explore another phenomenon explained by this strange science.